For this problem, we're looking at the limit as x goes to negative infinity of the polynomial x to the fourth minus x to the fifth. So here we are considering an end behavior of a polynomial, and the end behavior of a polynomial is dictated by the highest power term. And so what we're really looking at here for this is the fact that this is a negative x to the fifth polynomial. So a negative x to the fifth polynomial looks something like this. We don't know where the wiggles are and the shifts are in the middle, but we do know where those end arrows are. So the fact that it's an odd-powered polynomial is telling me that my arrows are going in opposite directions when we're looking at the left side and the right side of the graph. The fact that it is negative is telling me that those arrows are in kind of the negative slope direction. And so those are the end arrows, and what we're doing here is as we are looking at going off to negative infinity, we're looking at this one over here. So as x goes to negative infinity, that's telling me I'm looking at this end arrow for that particular limit. Well, we see that end arrow, as we are going off, as x is going off to negative infinity, it is going up forever without bound. And so that's going to be an answer of positive infinity. So really what we're doing here is we are looking at that first term, the highest power term. So the limit of this fifth degree polynomial is equal to the limit of the highest powered term. And we do have to hold on to that negative sign and any sort of coefficient that would go with that highest power term when we are computing these limits. And then we can rely on the idea of what the graph looks like to actually get the answer here. So we are looking at an answer of positive infinity. Another thing that you could consider here is once you've gotten down to just that single highest power term, notice that if we were to do arithmetic here with infinity or with negative infinity, it is actually consistent with what we know for the graph. Because if we think about plugging in negative infinity, we're plugging in negative infinity to the fifth power. Well, a negative infinity to the fifth power and negative to an odd power would remain negative. So we would really be looking at a negative times a negative infinity, which would be the positive infinity. But see, we got that graphically, and it's actually probably a bit cleaner to think about it graphically by looking at this arrow that we circled here too. Now, you do have to be a little bit careful when you are doing arithmetic with infinity because there are some things that are indeterminate, like you can't subtract infinity and really know what that means. Adding a couple of infinities, that would be fine. But when you're talking about infinity minus infinity, that would be indeterminate. So you do have to be a little bit careful when you're dealing with infinity, and that's why I utilized this idea that the highest power term for a polynomial is the one that's dominating. It's the one that's dictating the end arrows. So anytime you're looking at end behavior, meaning x going to positive or negative infinity for a polynomial, is that highest power term that you are looking at to find out what it is that your answer will be.